Hi, in this video, I am going to teach you about geometric sequences. By the way, geometric sequence is a sequence of numbers in which the ratio between consecutive terms is constant, while geometric series is the result of adding the terms of a geometric sequence. So in finding for the geometric series and sequences, we are going to use this equation. A sub n is equal to a sub 1 times r raised to n minus 1, where an is the nth term of the sequence, and a sub 1 is the first term of the sequence, r is the common ratio, and n here is also the nth term of the sequence. In order for us to get for the common ratio, we are going to divide the second term into the first term, as well as the third term into second term, and so forth. So let's try to find for the common ratio of this progression. 5, 10, 20, 40, and so on. As I've said, common ratio is second term divided by the first term. So we are going to get 10 and 5, as well as 20 and 10, 40 and 20 to get the common ratio. So we have 10 divided by 5 is 2, 20 divided by 10 is 2, 40 divided by 20 is 2. So in this progression, the common ratio is 2. And if you see that they have a common ratio, this means that this is an example of geometric sequence. But in this video, let's focus on the formula of geometric sequence, and this is the formula or equation. What if we are finding for the fifth term of this progression? So what is the value of a sub 1, or the first term of this element? It's 5. How about the value of r, or the common difference? It's 2. And how about the value of n? Since we are finding for the fifth term, the value of n is also 5. So by substitution, we have a sub 5 is equal to 5 times 2 raised to 5 minus 1. So a5 is equal to 5 times 2 raised to 4. a5 now is equal to 5 times 2 raised to 4 is 16. Then finally, a5 is equal to 80. So this 80 here is the fifth term in this progression. Next example, we have this geometric sequence: 6, 18, 54, and so forth. Let's try to find for the 8th term of this progression. What is the value of a sub 1, or the first element in this progression? It's 6. How about r? So 18 divided by 6 is 3. 54 divided by 18 is also 3. So their common ratio is 3. How about the value of n? Since we are finding for the 8th term of this progression, the value of our n is 8. By applying the formula, we have a sub 8 is equal to 6, because a sub 1 is 6, times 3 raised to 8 minus 1. A sub 8 is equal to 6 times 3 raised to 7. Next, a sub 8 is equal to 6 times 2187, because 3 raised to 7 is 2187. Then finally, a sub 8 is equal to 13,122. What if we have a decreasing progression? Let's try this example. 32, 16, 8, and so forth. And we are trying to get for the fifth term of this progression. What is a sub 1? Very good, it's 32. How about the common ratio? 16 divided by 32 is 1/2. 8 divided by 16 is also 1/2. So the common ratio is 1/2. And the value of our n is 5. So to apply, we have a sub 5 is equal to 32 times 1/2 raised to 5 minus 1. Next, we have a5 is equal to 32 times 1/2 raised to the 4th power is 1/16. Then a5 is equal to 32 times 1/16 is 2. So the fifth term in this decreasing series or progression is 2. Another example, we have 128, 32, 8, 2, and so forth. And we are trying to find for the sixth term of this progression. So again, what is the value of a sub 1, or the first element in this progression? It's 128. How about the value of r, or the common ratio? So we are going to divide 32 into 128, 8 into 32, 2 into 8. So 32 divided by 128 is 1/4. 8 divided by 32 is 1/4. 2 divided by 8 is also 1/4. So the common difference, or the common ratio rather, is 1/4. How about the value of n? Since we are finding for the sixth term, the value of our n is 6. So to apply the formula, we have a sub 6 is equal to 128 times 1/4 raised to 6, raised to 6 minus 1. So a sub 6 is equal to 128 times 1/4 raised to the 5th power is 1 over 1024. Then finally, a6 or the 6th term in this progression is 1 over 8.